Operation Argus. The secret nuclear tests in space. Operation Argus. The secret nuclear tests in space. In 1958, as the Cold War stretched into the heavens, the United States launched one of the most extraordinary and dangerous military experiments in history. Its purpose was not to conquer space, but to weaponize it. In total secrecy, the U.S. Navy fired nuclear warheads high above the Earth's atmosphere, detonating them hundreds of kilometers above the South Atlantic Ocean. The plan was simple, and insane. To see if a nuclear explosion in space could create artificial radiation belts around the planet, capable of disabling Soviet missiles or satellites. The operation was called Argus, after the all-seeing giant of Greek mythology. But unlike its namesake, this Argus didn't watch, it blinded. Its explosions lit up the night sky, created invisible walls of radiation, and temporarily rewrote the magnetic structure of the Earth itself. Only a handful of scientists and naval officers knew the truth. Even the crews aboard the ships didn't understand what they were witnessing: glowing clouds in space, strange electronic interference, and auroras that spread far beyond the horizon. For decades, the full story remained hidden, buried under layers of classification. It wasn't until years later that declassified documents revealed just how close humanity had come to altering the planet's atmosphere in a way no one could predict, all in the name of national defense. This is the story of Operation Argus, the secret nuclear tests in space, where the Cold War reached beyond the sky, and the Earth itself became the battlefield. Welcome to Secrets of Armies Chapter 1. The space race begins in the 1950s. The Cold War was no longer confined to borders or oceans. It had risen into the sky. The Soviet Union's rapid advances in rocketry and nuclear weapons had terrified the West. When the first intercontinental ballistic missile was successfully tested in 1957, it became clear that the next battlefield wouldn't just be on Earth, it would be above it. Then, on October 4, 1957, everything changed. A small silver sphere called Sputnik 1 crossed the night sky, transmitting a faint radio pulse that echoed across the planet. To the Soviets, it was a triumph of science. To the United States, it was a symbol of vulnerability. For the first time in history, a rival superpower could look down on America from space. Panic swept through Washington. If the Soviets could launch a satellite, they could launch a nuclear warhead into orbit. The sky was no longer safe. In response, the United States poured its resources into research that blurred the line between science and survival. It was an era of secrecy, of rapid experimentation, and of dangerous imagination. Among the many classified studies launched during this time was a program run by the U.S. Defense Nuclear Agency, known then as the Advanced Research Projects of the Navy. Their scientists were obsessed with a question: could the Earth's magnetic field itself be turned into a weapon? At the time, physicists were beginning to understand the Van Allen radiation belts, two massive zones of charged particles trapped by the planet's magnetic field. Discovered in early 1958 by Dr. James Van Allen and his team at the University of Iowa, these belts acted like invisible shields, protecting Earth from solar radiation. But to military minds, they also represented potential, a natural phenomenon that could be manipulated for strategic advantage. If a nuclear explosion could inject artificial particles into those belts, perhaps it could create new zones of radiation strong enough to disable incoming missiles or blind enemy satellites. It was a theory that combined science, fear, and power into one extraordinary idea. The concept was simple in words but nearly impossible in execution. To test it, the military would need to detonate nuclear weapons hundreds of kilometers above Earth, in near space, and study how the radiation behaved. The risks were staggering. No one knew how the upper atmosphere would react to such blasts. Would it create permanent damage? Could it disrupt communications, navigation, or even the planet's magnetic stability? The truth was, no one could say. Still, the logic of the Cold War prevailed. If the Soviets might do it first, then the Americans had to do it better. In early 1958, as the space race accelerated, the U.S. launched its first scientific satellite, Explorer 1, which confirmed the existence of the Van Allen belts. Just months later, a classified meeting at the Pentagon turned that discovery into a weapon proposal. The Navy and Atomic Energy Commission agreed. A nuclear detonation in space would be the ultimate experiment, one that could rewrite both physics and strategy. By August of that year, preparations were underway for a series of secret launches deep in the South Atlantic, far from any populated area, where the curvature of the Earth and the magnetic equator made conditions ideal for the test. It would involve a fleet of ships, a team of physicists sworn to secrecy, and modified nuclear-tipped rockets designed to reach the edge of space. The operation was given a name worthy of its ambition: Project Argus, the all-seeing one. But what it sought to see was something no human eye had ever witnessed before: the light of a nuclear explosion in the void of space. And what it risked was something no one fully understood. Chapter 2: The Mission in the South Atlantic. By mid-1958, the world was watching the dawn of the space age. But far from public view, in a region of the South Atlantic where few ships dared to travel, an armada of U.S. Navy vessels gathered for a mission that did not officially exist. At its center was the USS Norton Sound, a 563-foot missile ship refitted into a floating launch platform. Alongside her were support vessels, weather ships, and research craft carrying scientists from the U.S. Naval Research Laboratory and the newly formed Defense Nuclear Agency. Their orders were clear: test whether a nuclear detonation in space could alter the Earth's magnetic field and create an artificial radiation belt. The location was chosen with precision. Between Ascension Island and the South Atlantic Magnetic Anomaly, the region offered a unique window into Earth's electromagnetic structure. There were no cities below, no flight paths overhead, only open ocean and silence. It was the perfect place to hide a nuclear experiment that would break every known boundary of physics. The operation was divided into 3 main tests, each codenamed Argus I, II, and III. Each would involve a modified X-17A missile, launched from the USS Norton Sound and carrying a low-yield nuclear warhead, roughly 1.7 kilotons, smaller than Hiroshima, but still unimaginably destructive. The warhead would be fired nearly 500 kilometers into the upper atmosphere, detonating at the edge of space. Everything about Operation Argus was classified under the highest secrecy. Most of the crew had no idea what they were about to do. They were told they were participating in high-altitude weather experiments. Only a handful of scientists, and a few high-ranking officers, knew the truth. On August 27, 1958, the first missile was launched. The sky over the South Atlantic glowed with the white exhaust of the rocket as it pierced the atmosphere, vanishing into the thin blue above. Minutes later, the detonation occurred, far beyond sight or sound. But the instruments aboard the ships began to register something strange: spikes in radiation, fluctuations in magnetic readings, and faint electrical disturbances in the radio bands. The Earth itself had reacted. Over the following days, 2 more launches followed. Each detonation occurred at slightly different altitudes, allowing scientists to study the spread of radiation and its persistence in orbit. And what they found shocked them. Charged particles from the explosions became trapped in Earth's magnetic field, forming a temporary man-made radiation belt that circled the planet. It was invisible, silent, but powerful enough to disrupt the electronics and communications. For the first time in history, humanity had modified the planet's magnetosphere. One of the scientists aboard, Dr. Nicholas Christopoulos, had predicted exactly this outcome. He was a Greek physicist whose theory of artificial radiation belts had inspired the project in the first place. When the data confirmed his predictions, it seemed to validate his controversial vision that nuclear explosions in space could create electromagnetic barriers, potentially used as defense shields against incoming missiles. But the results also revealed something far more alarming. The radiation from the tests persisted for weeks, longer than anyone expected. Satellites launched afterward showed interference, and communications across parts of the South Atlantic faltered. No one knew if the damage would fade or accumulate. For a brief moment, the US military had literally changed the invisible fabric of Earth's environment, and no one outside that small fleet had any idea. When the final missile was launched on September 6, 1958, the mission was declared a success. Within days, the entire task force vanished from the region, leaving behind nothing but classified data and a few faint traces of radiation drifting through the upper atmosphere. Operation Argus was complete, the most remote, most secret, and shortest-lived nuclear test series in American history. But as the ships returned home, carrying reels of film and sealed containers of data, the question lingered among the scientists who had witnessed the results. Had they just discovered a new kind of defense, or a new kind of danger? Chapter 3: The Hidden Science. When the ships of Operation Argus returned to port, their decks were silent, their logs classified, and their data locked away under the highest levels of secrecy. Only a few dozen people in the world knew what had truly happened over the South Atlantic. To the outside world, the mission didn't exist. But inside the laboratories of the Naval Research Laboratory in Los Alamos, scientists were poring over a discovery that defied everything they thought they knew about Earth's environment. The data from the high-altitude detonations confirmed something extraordinary. Each explosion had injected massive quantities of high-energy electrons into near-Earth space. These particles spiraled along magnetic field lines, trapped by the Earth's magnetosphere, forming man-made radiation belts that persisted for weeks. The planet had literally been changed by nuclear fire. Dr. Nicholas Christopoulos, the eccentric Greek physicist whose idea had inspired the tests, was hailed as the quiet architect of the experiment. Years earlier, he had predicted that a nuclear explosion in space could produce exactly such effects. His theory, dismissed by many as impossible, now had proof. The world had seen its first artificial magnetospheric weapon. But the implications were darker than even Christopoulos had imagined. The radiation persisted far longer than predicted. Instead of decaying within hours, the artificial belts remained active for over a month, slowly circling the Earth and bathing satellites and upper atmosphere instruments in deadly energy. Even low-orbit spacecraft, like the newly launched Explorer 4, recorded abnormal radiation levels that interfered with electronics. For scientists, it was both thrilling and terrifying. They had successfully rewritten a piece of nature, and had no idea how to undo it. Behind closed doors, analysts debated what this meant for warfare. If a small nuclear blast could create radiation belts that disabled satellites, then a large one could, in theory, blind an entire hemisphere. Enemy communications, radar systems, and missile guidance could all be disrupted in seconds. Earth's magnetic field itself could become a weapon. But there was another question, one few dared to ask aloud. What if these effects were permanent? What if the magnetosphere didn't heal? In private memos, physicists warned that further detonations could accumulate radiation around the planet, posing long-term risks not only to satellites but to human life itself. Dr. Christofilos reportedly argued that the data proved such risks were manageable. But others, including Dr. James Van Allen, were more cautious. He understood what the experiment really meant, that the line between science and destruction had vanished. By late 1958, the classified reports from Operation Argus were circulating among a small circle of defense and atomic officials. The Department of Defense, the Atomic Energy Commission, and the CIA all saw potential in the findings. The possibility of space-based radiation warfare was officially noted in internal memos, though never publicly acknowledged. Meanwhile, the public remained in the dark. The world was captivated by the early stages of the space race, Sputnik, Explorer, and the birth of NASA, but no one outside a few secure rooms knew that the upper atmosphere was still glowing with the radioactive fingerprints of nuclear tests. Even the sailors who had launched the missiles were ordered never to speak of what they'd seen. For the next 3 years, Operation Argus remained one of the most tightly guarded secrets in U.S. military history. Its data became the foundation for new classified programs exploring electromagnetic pulse effects and high-altitude nuclear phenomena. And when the secrecy finally began to crack, it wouldn't be because of politicians or generals, but because of the scientists who refused to let their work be buried forever. By 1959, whispers of nuclear tests in space began appearing in technical journals and international conferences. Other nations, especially the Soviet Union, took notice. If the Americans had tested weapons in the sky, then they would need to do the same. Operation Argus had not just changed the Earth. It had opened the door to a new kind of arms race, one fought above the clouds, invisible and unstoppable. Chapter 4: Exposure and Reaction. For 3 years, Operation Argus existed only as a rumor whispered in scientific circles and among a handful of naval officers who had seen strange lights over the South Atlantic. The public had no idea that humanity had already detonated nuclear weapons in space. But secrets have a way of drifting, and by the early 1960s, the radiation itself began to tell the story. It started with the satellites. When new spacecraft were launched into orbit in 1959 and 1960, they began returning unusual readings. Radiation levels were higher than expected, far higher. The newly discovered Van Allen belts showed disturbances that didn't match solar activity. To scientists who understood the data, there was only one explanation: someone had detonated nuclear weapons above the atmosphere. Then, in 1959, word began to spread through the global scientific community. A quiet report authored by Dr. James Van Allen, the same scientist who had discovered Earth's natural radiation belts, hinted that artificial injections of charged particles had been observed in the magnetosphere. It was a cautious phrase, but for those who knew what it meant, it was an admission. The Americans had done it. When the story finally reached journalists in 1961, it caused shock and disbelief. The idea that nuclear explosions had taken place in space, deliberately, sounded like science fiction. But soon, the details emerged: the secret launch fleet, the modified X-17A rockets, the radiation belts that had lasted weeks. Operation Argus was real, and it had changed the Earth's magnetic environment. The revelation came at a time when Cold War tensions were already rising. Just months earlier, the world had stood on the brink of nuclear war during the Berlin crisis. The Soviet Union had resumed its own atmospheric testing program, detonating the monstrous Tsar Bomba in 1961, the largest explosion in human history. Now, the idea that the United States had also tested nuclear weapons in space added a terrifying new dimension to the arms race. In private, Soviet scientists expressed both awe and outrage. They understood the implications immediately. If nuclear detonations could alter the radiation belts, they could also disable satellites and radar, the very systems both sides relied on to detect missile launches. To the Kremlin, Operation Argus was not an experiment. It was a weapon test. Within months, the Soviets began planning their own high-altitude nuclear detonations. In 1962, under the codename Project K, they conducted several explosions in near space, creating their own artificial radiation belts and electromagnetic pulses that disrupted communications across Asia. The Americans responded with Operation Fishbowl, detonating multiple nuclear warheads high above the Pacific, including the now infamous Starfish Prime test, which knocked out power grids in Hawaii nearly 1,500 kilometers away. It was the moment humanity realized just how fragile the upper atmosphere truly was. Each blast left its mark, radiation lingering for months, satellites crippled, and strange auroras glowing across the night sky. The Earth's magnetic shield had become a laboratory of war. By 1963, the world had seen enough. The Partial Test Ban Treaty was signed that August, prohibiting all nuclear detonations in the atmosphere, underwater, and in outer space. Publicly, it was a diplomatic achievement, a sign that the superpowers were stepping back from the brink. Privately, it was an acknowledgement that they had gone too far. When the full details of Operation Argus were finally declassified in 1959, and more thoroughly in 1982, scientists around the world were stunned by the scale and recklessness of the mission. The data confirmed what many had suspected: the artificial radiation belts had temporarily enveloped parts of Earth, exposing spacecraft and astronauts to increased radiation levels for years afterward. What had begun as a secret military experiment had quietly altered the natural balance of the planet, all under the belief that it could make the world safer. But as one naval physicist later wrote, Operation Argus proved that our power to destroy had surpassed our wisdom to use it. The operation's secrecy had shielded it from scrutiny. But now that the truth was out, it forced the world to confront a haunting question: if we could change the planet once, who's to say we wouldn't try again? Chapter 5: Legacy of the Atomic Sky. When the last details of Operation Argus were declassified, the world finally saw the magnitude of what had been done, and how close it had come to rewriting the laws of nature. 3 small nuclear explosions in space had proven that humanity could alter the invisible shield protecting the planet. The Earth's magnetic field, once thought untouchable, had been forced to bend to human will, even if only for a few fleeting weeks. To the scientists involved, Argus had been both triumph and warning. It demonstrated the terrifying reach of nuclear technology, but it also exposed how little anyone understood about its consequences. Even decades later, radiation from high-altitude tests like Starfish Prime could still be measured in parts of the upper atmosphere. The data gathered from Argus would go on to shape everything from nuclear strategy to modern space science. The operation confirmed that electromagnetic pulses, EMPs, generated by high-altitude nuclear explosions could cripple communications and electronics over thousands of kilometers. That finding became a cornerstone of Cold War doctrine. If nuclear war ever erupted, the first weapons to detonate wouldn't be aimed at cities, but at the sky. The battle for Earth would begin above it. For physicists like James Van Allen, the results of Argus inspired new scientific missions to study radiation, magnetic fields, and cosmic rays. But for military planners, the same results meant opportunity. Classified research programs continued into the 1970s, exploring whether artificial radiation belts could be used for missile defense or satellite disruption. The weaponization of the magnetosphere, once a science fiction concept, was now a chapter in U.S. military history. Operation Argus also left a moral scar. It revealed a truth that would echo through every military experiment that followed: that secrecy and science, when combined, can push civilization beyond the limits of reason. The sailors who had unknowingly served in the mission were never fully told what they had participated in. Many died never knowing they had helped create man-made radiation belts circling the Earth. And yet, the legacy of Argus did not fade entirely into darkness. Its data, once meant for weapons, helped scientists understand how the Earth protects itself from solar storms, knowledge that later saved satellites and astronauts during space missions. From an act of Cold War paranoia came tools that would help humanity explore the cosmos safely. But the ethical shadow remains. Argus was a glimpse into a possible future, one where human power extends beyond the surface of the world, shaping invisible forces for war. It asked a question that no treaty or experiment has ever fully answered. If we can change the sky, what will stop us from doing it again? In the decades since, new military programs have emerged under different names, testing high-energy lasers, plasma manipulation, and electromagnetic interference. Each time, the same argument returns: that knowledge itself is neutral, and only its use determines right from wrong. But Operation Argus showed the danger in that belief. Because once knowledge is born in secrecy, it rarely stays neutral for long. Today, the radiation belts above our planet remain natural, stable, and invisible, a silent shield that protects all life below. But deep in that shield, somewhere between science and memory, the faint traces of humanity's first nuclear fire in space still drift. They are the fingerprints of a moment when mankind reached beyond its world, not to explore it, but to see if it could survive its own reflection. The day we touched the sky, they said the sky was eternal. That it belonged to no one, not to kings, not to armies, not to empires. But in 1958, mankind proved that even the heavens could burn. Operation Argus was not a battle, but a question, one asked in silence and answered with light. It showed what happens when fear and science merge, when the boundaries of the Earth are no longer enough, and when the pursuit of security becomes indistinguishable from the pursuit of control. 3 explosions, hundreds of miles above the ocean, invisible to the world below, yet their echoes reached everything. For a few brief weeks, the planet wore a new crown, a ring of radiation forged by human hands. A weapon that could blind the stars themselves. And when the lights faded, the lesson remained. That power without understanding is the oldest danger of all. That secrecy, once unleashed, reshapes not only policy, but nature itself. And that the greatest battlefield is not land or sea, but the thin blue veil that separates us from the void. Today, the sky looks peaceful again. But peace is fragile. Above the clouds, satellites orbit in silence, descendants of the same science that once threatened to poison the heavens. We stare at the stars and call it exploration, but somewhere in their reflection lies a warning. Because the day we reached for the sky, we left fingerprints on it. Thank you for watching. If you believe history's most dangerous secrets must never be forgotten, like, share, and subscribe for more stories from the dark edge of discovery, where science and war become one.